Okay, so in this video we're going to start discussing the natural base, which is e. So we'll talk a little bit about what each one of these are. So we're dealing with logarithms and exponential functions still. So we have this natural base though because certain things grow exponentially in nature, or decay exponentially in nature. It happens on a continuous basis. So for example, we've talked about like bacteria growth. That could be a continuous growth. So we want to model that appropriately. And so what we use to do that is this letter E. It's actually a number. So we're going to talk a little bit about the number and the natural log, which is its inverse. So we still have an exponential function. So just talking in terms of what we've seen before regarding logarithms is we know that if we were to graph an exponential function, we would see this type of growth, right, if it is a growth function. And then we know that a logarithmic function is its inverse. Okay, so we have the same idea here, that we have our exponential function here, and then we have our logarithmic function here, and they're inverses. And you've seen this in a previous video. And now we have an exponential function for e, which is going to be pretty much the same as our exponential function. Specific numbers would vary slightly depending on what's going on in the situation. But we have the same pattern here, and our natural log is going to be the inverse of that. Okay, so we're dealing with the same situation. We just, because of certain things growing on a continuous basis, we have a different value that we use to calculate it. And so this is the natural base. And so a couple things real quick. We have an exponential function with base e. So this is our exponential version when working with the natural base. And this is our log version. We use natural log, which you can locate on your calculator right below the log button. We could also say log base e of x. And a lot of times I like to think of it this way because we're dealing with something at base e. Now, if you take on your calculator and you plug in e, and I'll do a quick video in conjunction with this showing you how to work with E on your calculator. But we'll go through this video for specifics or hop back and forth between the two. E is an irrational number. It's just like pi, and it goes on forever. And approximate E is 2.7182. Okay? So what type of problem here? So let's just kind of work with it. If I want to write this expression in its alternate form, I do the same thing that I would with any exponent. I would use that connect the dots method or the spiral method, whichever you prefer. And so I know I have a log base e of 8.7875 is equal to x. We really don't write log base e. I just do that because it's connected to what we've already done with logarithms. So it makes it a little easier to adjust to now this base e. Base e is really just the natural log. So it's natural log of 8.7875. And then so this one, if I want to go ahead and write it in an alternate form, which we're going from logarithmic to exponential in number 2, what I do is I'm going to write in a base here. I'm going to write in that e, and that just helps me understand what I need to do here. So e to the x is equal to 2, and those are the alternate forms. And so notice that we're doing the same exact thing that we did with just the common logarithm and just those generic exponential functions. It's no different than what you've done before.